Buddy? Sorry for the delay. I guess there were some audio issues. How's everybody doing today? Excellent. So, this is a kind of a blend of a lot of talks that I usually give because I flew all the way out here and I don't get to see all you lovely people very often. I decided to try to smash as much content as possible into one talk. So, this is Python for Humans, the remix, basically. So, hello, my name is Kenneth Reitz. I work for a company called Heroku, who is sponsoring the conference, and we are a really great web application company for hosting your web applications. So if you want to learn more about that, and come talk to me afterwards, and I think I'm doing a demo in open spaces later if you want to learn more. I'm also a member of the Python Software Foundation, and we're going to be switching our membership design soon. So in the future, you'll be able to join, anybody will be able to join the PSF, which will be really exciting. So keep your eyes out for that in the near future. If you know who I am, it's probably from the open source code that I've written. If you go to my GitHub page, which is at github.com/KennethReitz, you'll see about 18 serious projects, a lot of experimentations that I've made. Requests and OS X GCC installer are my two most popular projects, but we're going to get into those more in a moment. So who here uses Python? All right, excellent. So Python is a really great language compared to a lot of other languages, at least I believe, because of the philosophies that Python kind of undergoes and takes. We all share this really dark past often, if Python wasn't our first language. We've used Perl, we've used Java, PHP, Cold Fusion, Classic ASP, all these horrible, dark, evil languages. And Python has a lot of philosophies that we think are a lot better than that, and that a lot of these other languages don't do. And if you go into a Python interpreter and you type import this, you will see the Zen of Python, which is basically a short collection of phrases that explains what the philosophy of Python is. Some of the best things that are in this document are beautiful is better than ugly. A lot of languages don't really care about the aesthetics of the code or the APIs that people build, and Python makes it really easy to make very elegant, simple code. It has a very simple syntax, and tries to avoid things like unnecessary brackets by using whitespace. Explicit is better than implicit. A lot of languages like Ruby will put a lot of emphasis on like certain variables just kind of being globally available that you've never imported and things like that. And it creates a lot of confusion when you're writing code. In Python, everything that you use should be imported explicitly, and that kind of extends to the language. You can do some magic things in Python, like you can modify the globals and the locals dictionaries, but you're not supposed to do that. So it's similarly powerful, but constraints are good. Simple is better than complex, and complex is better than complicated. If the implementation is hard to explain, then it's a bad idea, unless, of course, you are PyPy, because in PyPy is impossible to understand, but it's a great idea. And this is the most important one that we're going to touch today, and it is that there should be one, and preferably only one, obvious way to do it, to do anything. A lot of languages like Perl and Ruby kind of pride themselves on expressiveness, the expressiveness of the language, instead of the having it be really simple and have there being one way to do things. And that kind of extends throughout the entire language. In Ruby, basically, if you go and work on a team, you'll have to learn the way that team works every single time you go to do a project, because there's so many different ways to do simple tasks. And in Python, we always try to have there be a single way, and that really gives us a lot of benefits. So, you've decided that you want to learn Python, the new language, you're really excited. Welcome to paradise. You finally found a language that is going to be really exciting, and it will, the philosophies kind of resonate with you. These are people who really like the things that you like. It turns out that's not actually true at all, and it's really disappointing. So, let's pretend that we know Ruby, and we're going to take a little piece of example code that is written in Ruby, and we're going to convert it to Python, and we're going to see what it's like. So here in Ruby, the first thing we do is you import the HTTP library, net/HTTP, and a URI module. Then you take your API. We're going to hit the GitHub API with a username, pretty simple, standard stuff. So you take the URI, you parse it, and then you create a new HTTP connection from the host and the port from that URI that you parsed. You're going to tell the connection to use SSL, and then you're going to make a new GET request and add basic authentication to it, and then you get your response. It's not the most straightforward thing in the world, but there's nothing in here that's unexpected. Everything in here is very explicit. There's nothing in here that is surprising. So, the first thing you have to ask yourself when you're trying to write this in Python is what is Python's version of the net HTTP library? When you search online, you'll find a multitude of answers for this. You'll see httplib, urllib, urllib2, httplib2, urllib3. There are many, many answers. And it's a little confusing. So several hours later, you'll find that urllib2 is the most common answer that people recommend on the internet, and that's recommended in the standard library documentation. And this is the code that you're going to have to write to do the same thing that we just did in Ruby in Python. You're going to have to import urllib2, you have your URL, you create a request from that URL, and then you create an HTTP password manager with a default realm called the password manager, add the password to it with your username and password, create an authentication manager from an HTTP basic authentication handler, and you pass in the auth manager into the basic manager. Then you build an opener with the auth manager, then you install the opener, and then you can create a handler, and then you can read the response. What the hell? This is ridiculous. This is the most complicated thing I've ever seen in my life, and this took hours and hours of work, and it shouldn't be that hard. So admit it, if this was you, you would probably leave Python and never come back. You know, this is a language in a community that says that they're about all these really great things, but then when you go and look at the code like this, it appears as though it's actually the opposite that is true, and it's very disappointing, you know, because you had so much hope in this language and this community, and it was so exciting, and, you know, like why, it's just a bunch of hypocrites, right? The problem here is that it's unclear which module you're supposed to be using in the first place. Everyone online seems to recommend urllib2, but the docs are really bad. You have to go find blog posts and stuff like that to figure out how to use the module. And once you do figure it out, it has a really bad API. So this is a really serious problem. HTTP should be as simple as a print statement. The whole internet that we use today and everything that we build is usually based around HTTP. And when we have no simple way of interacting with such a common layer of application interaction, it causes a real problem for developers. So the solution to this problem is relatively simple. Basically, it's really important to build elegant tools to perform these tasks. This is something that every developer probably has to do at some point or another. There's no reason it should be so difficult for 90% of the users to have to do this. Python needs more pragmatic packages. So pragmatic means dealing with things sensibly and realistically in a way that is based on practical rather than theoretical considerations. I like to call this Python for humans. So let's break it down. What is HTTP at its core? Basically, it's a fairly simple system. You have a set number of methods with consistent parameters. You have a couple different methods here. You have head, get, post, push, delete, stuff like that, fairly straightforward. And they all accept headers, URL parameters, body, and form data. The urllib2 is the opposite of that. It doesn't expose any of these things built in by default. It doesn't have any of the different methods. It doesn't support form data very well. It just kind of automatically does all this stuff that you don't expect it to. It's very over-engineered. It ignores most of PEP 20. The docs are almost impossible to read. HTTP is actually really simple, and it's just the opposite of what it should be, basically. I don't like this. So, I wrote this library called requests, which a lot of people like, and it is supposed to be HTTP for humans. So to do this exact same code in requests, you just import requests with your username and password, you make your GET request, and you get your response, and that's it. Yes. Oh, thank you. Achievement unlocked. We have a small set of methods with consistent parameters. We have a get, a head, a post, a push, a delete, and they all accept headers, URL parameters, and form data. Do this. Do this for everything that you ever need to do. The litmus test is if you ever have to refer to the documentation every time you use a module, then you need to either go find a new module or build a new module. That makes it easier for you and other people to do the same thing. And to do this, I think it's really important to fit that 90% use case. If you look at the urllib2 API, it's really cumbersome and hard to use because they're trying to fit in every possible use case that anyone could ever have into the API. And by doing that, they make 90% of the users who just want to do simple HTTP requests, and they make their lives miserable, trying to bend over backwards for the other 10% of the people. And the API is really all that matters in libraries like this. All the other things are secondary. And I mean like performance, security, all these things. They're all very important, but they're not nearly as important as the API itself, because that's what all of your developers interact with. So there's this really great quote by Steve Jobs that I found a couple months ago. He had, right before he passed away, or right after he passed away, there were these tapes that were leaked on the internet. That was like it's a secret interview with him, basically, that was several hours long, from 1983, before Apple was really that popular. And there's a really great quote in there. So it goes like this. Steve Jobs was talking about the Apple computer, which again was not, it was kind of like his new idea of people having personal computers in their homes. And this is what he said. People are going to be spending 2 or 3 hours a day with these machines, with these computers, which is more time than they spend in their car every day. So software design must be given at least as much consideration that we give automobiles today, if not a whole lot more. I think that's really important. I think that really worked well for Apple. They put a lot of work into all the design, the software, and the hardware that they build. And that really worked out. That's responsible for all the design decisions they've made. And that's for people who spend 2 or 3 hours a day with these machines. If you're a developer, you're going to be spending 8 hours a day with APIs that people build, or the other people will be spending that much time with the APIs you build. So you need to build things with as much care and dedication that people put into automobiles and cars, into your APIs. And you should build it for yourself, a developer. Don't build the code for the code. You build the code for you, and you try to make it easy for you. It is a really difficult thing to do, and I find it really useful to write the documentation first in order to do this. So before any code is written at all on one of my projects, what I'll do is I have a new idea I want to build. I'll sit down and I'll actually write the README for the project before I actually write any code at all. I'll sit down and I'll just write some examples of what the code will look like and how to use it. And then you go through all the different steps. And you show some examples of this is what you're going to call, this is what the results for this function call will be. And then you write some pretend code with that. You actually use it before there's any code written at all. And it makes things a whole lot easier. And this kind of shifts the whole way you think about the problem that you're trying to solve. Instead of engineering something to get the job done, you interact with the problem itself, and you build an interface that reacts to it. It's basically like responsive design. Where you were working on a website, and you give it a responsive design, it'll work well on a phone, it'll work well on a tablet, it'll work well on a computer. It's not about that, though. It's about making something that understands itself enough to fit the problem space. You have to put a lot of work into making the website that you're working on just work for the users. And you have to do the same thing with your APIs. You make it really simple for the users, and there's a lot of complicated steps that are involved in between those two things, and you need to make all that work happen in the background. So sculptures kind of work the same way. If you have like a really great artist who's making a really great sculpture, they aren't like engineered or manufactured. They don't just go in and know exactly what they want to build and just go find a piece of stone and do it. They study a piece of marble. They'll go and they'll get a piece of marble and they'll try to study it and learn about it and try to understand what is inside of it. And then he responds. He tries to set free the sculpture that was hidden inside of the stone all along. And it's the same thing with APIs. If you go through and you try to actually interact with the problem at hand instead of just kind of forcing it out, you can build a really nice API that people like, and it'll save a lot of people a lot of time. And when you do this, you should open source it, because open source is awesome. Who thinks that open source is awesome? All right, everybody. Yes, open source is amazing, and it's changing the world. But what is open source, right? There's a lot of different ways to describe open source. Sometimes you just hear it's things with the MIT license or the GNU license and stuff like that. But really what open source is, it's like a world movement. It's a transparent group of distributed developers working together to make software and projects that make the world a better place. And if you look at the things that are happening in the world, some of the most important things that are happening right now on planet Earth are a result of open source software. If you look at all these different social media things that people build, and HTTP, and just like social media, different elections happening, you see like tweets happening constantly. An election, you can like determine who's going to win an election before it actually happens based on the tweets alone. You have journalism tools, things like WikiLeaks, wars are being started. All of these things are all a result of the tools that people are building with open source. And it's an incredible thing to see the whole world change because of developers. There's a phrase that developers are the new kingmakers, and I really think that's true. So we have a really unique opportunity to take part of this powerful social movement and create a part of these tools that are changing the world. And it's pretty exciting to be able to do that. I don't think there's any other time in human history where Any person can just sit in the corner in their house, on the other side of the world and just type on their computer for a while, and then that inadvertently end up changing the world. Like Mark Zuckerberg sitting in his dorm room at college probably had no idea the effect that he'd have on society at large, but he did, and it was based on open source tools. But open source by itself isn't very useful if you don't document it. Documentation is really the glue that makes open source possible. And it's really important if you're going to make a library or make something that tries to make developers' lives easier or make people's lives easier, that you communicate what it's for, what it's about, and how to use it in a really good way. And that's all about documentation. So there's some examples of good open source, and there's examples of bad open source. If you look at bad open source, there's some projects that are not the best. There's GitX, which is kind of confusing because it appears to be unmaintained, and there's like 20 different forks of it. You have the Facebook SDK, HTTPlib2, Hubcap, OAuth2. These are libraries that at one time people liked and they were really good, but today they're very stagnant. It's unclear what's happening, and they fail to solve a clear problem, and they have unclear expectations. If you look at really great open source projects like Jenkins, Python, Django, pip, bundler, all these projects that thousands of people use, they're really great because they solve a clear problem, they communicate well with their users, and they manage their expectations realistically. And this is a direct result of them having really great documentation and communicating their intent and their purpose to their users. So write more documentation. Document everything. I think that's really, really important. There's some really great tools for writing documentation. You can, there's a great service called Read the Docs that you can go to, and it lets you host Sphinx projects without having to do any work at all. It basically makes it as easy as throwing a project up on GitHub. And I think just that tool alone makes it really, really easy to write documentation. And I recommend everyone check it out. Eric Holscher, the guy who runs the project, actually has this repo where he tries to document his entire life on Read the Docs. It's pretty cool. So he'll write all of his journal every day and his thoughts and feelings. I think his blog is hosted on it too. It's ridiculous, but it's pretty cool. So I've maintained quite a few projects, and I've learned quite a few things while I've been doing that. And I'm going to go over some of those things for when you release your next project. And the most important thing that I've learned is to be cordial or be on your way. So if you're a contributor to a project, it's really important to keep all of your interactions with the maintainer as respectful as possible. When you think about it, the person who's maintaining the project that you're interacting with has probably sacrificed a tremendous amount of their time to make that code available, to maintaining it, to responding to their users. So if you act towards the maintainer like they owe you their time, that can be really draining on them. And so really you need to act as though they don't owe you a moment of your time, and that's really important because it can be really stressful to have thousands of people using your software and complaining about it and stuff like that. But if you're a maintainer, you should do the opposite. If you maintain a project that you released out there, and the world is using it, then you have a crucial responsibility of being immensely thankful to all of your contributors. They're the lifeblood of your project. They're the reason your project exists. They're the reason it's useful to anybody, and they're the reason that your code is worthwhile. So you should ignore non-constructive feedback, and that's the most important thing. A lot of people will complain about things that they don't like about the project, or they'll that can be a really good thing if they're being constructive. You can have negative constructive feedback, and that's really great. But a lot of people will just kind of whine and complain, and it'll be unconstructive, and it's really important to learn to just ignore those people completely. And that really helps maintaining projects quite a bit. And it's really important to also remember that some people just take things way too seriously. You'll make one little change to a project, and it'll cause one guy 5 minutes pain, and he'll go on a big Twitter rant and write some blog posts, and it'll be #1 on Hacker News. And it's just really important to just remember that we're supposed to be writing software because it's fun, right? We're hackers, and we like to build things, and we're tinkerers, and we're trying to change the world. We're not trying to make everyone have a bad day. And it's really important, if you're maintaining a project that a lot of people use, to be very cordial towards the people that are using your software and that are contributing. So you need to be really careful with the words that you choose. A lot of projects will operate in a way where if someone sends a pull request that doesn't have any tests or does something to disagree with, they'll just kind of close it without saying anything, or they'll just kind of rudely be like, no, and that's all they say. It's really important that if you're maintaining your project and responding to something like that, you need to remember that contributors can take what you say really, really personally. You'd be shocked at how many times I've gotten a pull request and I've kind of helped the person along trying to make it better, or tell them why and be very appreciative of the work they've done. And they'll say that that was the very first interaction with open source they've ever had. And a lot of times what happens is someone has a project they like, they'll try to contribute to it, they don't really know what they're doing, and they're horrified of pushing this code out there and the criticism that could happen and that they could face. And if someone is negative towards them on their first interaction, they might never code in open source again, and that's horrible. That's the opposite of what we should be trying to do. A lot of our careers are built around open source, and we should always be trying to extend that in as many ways as possible. So if someone has a pull request they send you, or an issue and it doesn't make sense, instead of just kind of brushing it off, you should try very hard to educate the user, to try to make their world better and yours. And it's really important to remember that a little bit of kindness goes a long way. So when I get a pull request, basically, no matter what it is, no matter how small, I always try to add the person to the authors file afterwards, even if it was a simple typo fix. And I'm always very thankful to the person, no matter what, and that really helps a lot. You'd be shocked at how often you send a pull request to another project, and the people will be rude about it, or they'll just merge it without saying anything. So yeah, be kind to your users. It's really important also to avoid burnout in a project. Sustainability is the most important part of any open source project, and it's really important to remember that everyone has a limited amount of time. So it's easy to become the bottleneck of your own projects, which really sucks. If you're having a bad week, all the issues will start to pile up on your projects, and it'll be this big stress. So this coworker of mine named Wes is really great. He maintains a library for Ruby called Fog, which is quite popular. It's kind of like an ORM for different cloud services and infrastructure providers. And he says that open source provides a unique opportunity for the trifecta of purpose, mastery, and autonomy. By recognizing the power of these factors, we can keep ourselves motivated and continue to increase our impact. It's really important to keep in mind all of these separate things at all times when you're maintaining a project and working with other people. It's important to make sure that all of the users and all the people that are contributing and using your project feel like they have a purpose in the project. It's important to reward the people that have done a good job. And it's important to automate it so that you don't have to do a lot of monotonous work. A great service for this is called Travis CI. So whenever pull requests come in to any of my projects, the unit tests will automatically get run, and GitHub will know if they pass or not. So I never have to go and pull the code myself and check. It always happens automatically, which saves me hundreds of hours of time, and it's really great. So these two people that I met also help with the sustainability problem quite a bit. Their names are Corey and Ian, and these guys are like the best people in the world, basically. What happens is when a pull request comes into requests, or a lot of other projects that I run, these guys will triage it. So like, I'll be on a plane, or I'll be in India, for example, at a conference, and usually what used to happen was I'd get really behind on my open source work, and I'd just have this big backlog of issues that were like 2 weeks old that I couldn't respond to. So these guys just one day started like commenting on issues and telling me which ones needed to be closed. They would respond to people and help them out. So one day I just started collaborating them, added them as collaborators on the repo with commit access, and they've been tremendously helpful in maintaining the project. And it's another thing that Wes says a lot, is that it's really important to learn how to do less in open source. To let it be more sustainable, let other people just kind of get out of their way and allow them to help you run the project. And they saved me like a tremendous amount of time, and it's been very, very valuable. So it allows me to focus my time on larger issues and help contributors make the best time of their efforts. So like usually within an hour of opening an issue, someone will have responded to the issue, and that's fantastic, because these guys, if you have to wait a week for an issue or something like that you open, like it's a good chance that you're not interested in fixing the problem anymore. And so reducing that amount of turnaround time is fantastic. Corey tweeted this a couple weeks ago. He said, as I fork another one of his projects, it occurs to me that I don't program in the Python ecosystem. I program in the Kenneth Reitz ecosystem. And this is a kind of ridiculous thing that he said, but it's really valuable. So if you take if you have a project and you let other people kind of get involved and you encourage them to do these things, it's rewarding for everybody. It's great for you because you get to save a lot of time. It's great for you because then they get more involved in your other projects that you're running. And if you start a new project, they can help you maintain it and share the burden. And it's really great for him because then everyone knows this guy's name from all the projects that he's always responding to. And it's helped a lot. This is the most important one that I've learned, and it's kind of the most difficult one when running any project. It's learning how to say no. Basically, people are going to ask for the most ridiculous features that you can imagine and send pull requests that kind of seem harmless, right? They'll add this feature that they need for their thing they're doing at work or whatever, and they're really trying to make the project better. They have good intentions, but it's really important to say no to a lot of those features. Because if you keep maintaining these projects and you keep adding all these features that people are sending to you without really keeping in mind how simple the project needs to be, your project will soon be ruined. It's called the tragedy of the commons. If you let everyone rule over the decisions that your project makes, then it will turn pretty nastily pretty quickly, and it's not very fun, and it makes it really hard to maintain. So this is Peter Hitchens had a great quote. He's the CEO of the company behind ZeroMQ, and he says that simplicity is always better than functionality. And I think this is really important in most things in life, but specifically for open source. So open source is great because it's small, it's distributed, and it's focused on small problems that are easily solvable. Things that have a separation of concerns. So if a new pull request comes into one of my projects, now if it adds some complexity to the project or in a new feature that isn't needed by most people, I say no to it, basically. And I feel like that's it's really, really hard to do that. And at first I used to merge basically anything that someone sent, and I feel really bad if I didn't. But now, after years of doing that, I realize what a bad decision that is. And it makes so much of a headache for you. And if you learn how to say no like this all the time, it helps you learn how to build more composable code. So, for example, requests used to have SOX support built into it for SOX proxies, as well as gevent and a couple other things like that. And it was really great, but I don't know anything about SOX. It also supported Kerberos at one time. I don't know anything about Kerberos, and neither did any of the maintainers. So having that piece of code be in the code base didn't make any sense because we couldn't maintain it, we didn't understand it, we didn't test it, and when it broke, we had no idea how to fix it. So learning how to say no taught us to re-architect the code base so that someone else could provide that functionality in another library. And that helped the project tremendously. So basically, it's always a good design decision to try to figure out how to add the fewest lines of code possible in any project. Simple code is always better than complex code. Code solves problems that are created by humans. So the less code there is to maintain. Negative diffs are always the best. If a pull request comes in and all I see are green lines and no red lines, then it's a really good idea to really consider if that's necessary for your project or not. And this allows you to build really sharp, small things that are focused on close problems that make it easier to sustain. Complex code, I believe everyone can agree, is a horrible thing. Tight coupling, monolithic code bases, these are all things that we hate to maintain, and they're all the bane of a lot of our existences. I think a lot of companies hire people to just go maintain these crazy these crazy old code bases that no one wants to touch. And when that happens, it's really easy to have this lurking, growing technical debt in the project, and it's never a fun thing. So if you keep it simple, you keep your maintenance burden down, and the code will become problem-solving instead of self-serving, which is always a bad thing. So say no to all the things. So that's most of the talk. The manifesto for the takeaway is open source makes the world a better place. Please don't make it complicated. That's all. Okay. 10 minutes? All right, cool. We have time for questions. So anyone have any questions? I don't know if we have a mic to pass around. We do. Excellent. No one has any questions at all.
Hi. Like you mentioned about urllib2. So, if you want to store the state, you want to have a stateful session. Like you want to store cookies. So, can you use urllib2 or requests, or do we need some sort of a browser emulator like Mechanize or something? Can requests do it?
Yeah, so I've designed requests in a way where it can, it has a session and it'll persist cookies automatically. It doesn't behave exactly like a browser, but it will do most of the things that you want. It'll store cookies that are sent by the server. It'll allow you to set them and it'll persist them just like a browser would. And then it'll also do connection pooling automatically. And that works really well. If you're doing it with, you can do it with urllib2, but it's kind of ugly. You have to mess with these cookie jars and stuff, and it doesn't really make much sense. And in requests, it's automatic. So, yeah, that's an intentional design decision. And I think I would like to add more browser functionality eventually, because I think it's really useful and it's what people expect.
And how do you compare it with Mechanize, like requests with Mechanize, if you've heard of Mechanize?
I haven't used Mechanize a ton myself. I know a lot of people have found requests to be better for them, and I've seen some people write some adapters that kind of make them play nicely together. There was one at PyCon, I can't remember what it was called, but you can use like a headless browser with requests. So I wrote these things called connection adapters, which allows you to just kind of define the entire application or socket sending logic. And if you really wanted to, you could actually have the request API connect to Mechanize and do it that way if you really wanted to. So ideally, they both play nicely together, but I think it really depends on your use case.
Thank you, Kenneth.
Mm-hmm.
Yeah, hi. So, let's say you have a great idea, like you did with requests, and you start writing code. So, obviously, you need a lot of people to help you out, that's the idea of open source.
Yeah.
Could you talk a little bit about how you got requests to where it is right now? Because I'm pretty sure a lot of us here have great ideas, but we just don't know how to, get started and, get the traction that it really needs for it to become something like requests is.
I think the most important thing is documentation, really. I think a lot of projects, they have really great ideas, but when you go to the repository, it doesn't actually explain what the project is, or how to use it, or how to install it. So I think there's two things. It's making the barrier to entry very low, so it's very easy for someone to try it right away to tell if it's good or not. Because if it's not obvious how to use it, they'll just go look at something else. And then if they want to learn more about it, sometimes people just will have them go look at the source code. And ideally, you should have great documentation that explains all of the philosophies and the design decisions behind the project. And I think that really goes a long, long way. And if that, if it's a good idea, then it's communicated well. And if it resonates with people, it'll just naturally take off. And that's kind of what happened with me. I wrote a bunch of projects. I had one in particular called TabLib, which a lot of people use, but not nearly as many as use requests. And I had the same type of documentation and stuff, and it wasn't nearly as popular just because it wasn't as good of an idea, basically. So it's kind of a combination of all those things. And I think that really goes a long way.
Hey, how are you? I have no questions, but just wanted to thank you for an awesome keynote. I hope everybody agrees here. Thank you.
Thank you.
Hi, thanks for a great talk. It was very inspiring. So, in terms of like TDD-driven development versus the like documentation-driven or README-driven development that you're saying,
yes.
What's your take on that?
I think go ahead.
I personally like reading tests that are working.
Yes.
And reading the implementation from that.
So it's interesting because I think README-driven development is actually a form of test-driven development. It's just not usually tool-driven. So basically what you're doing, you're writing the README, is you're basically writing an integration test that you're just checking manually. And there's some tools that do this. You can use doctest and have it be automated, so it'll actually test that as you write it. But I think probably the best practice thing to do is to write the README, get it started, and then you start writing tests for all those components. You write a bunch of integration tests, and then once you get the idea formed, you go and you can write a bunch of unit tests. Unfortunately, I usually never get around to the unit test part. at all. And I usually, when I'm actually starting development, I personally don't even write the integration test until I'm done. I know that's something that a lot of people recommend and do. So I think it's kind of a personal decision, but I think that they both fit together really well. Yes.
Great talk, Kenneth. Quick question. How do you gain insights into how people are using your API and libraries?
What do you mean exactly?
So once it's out there and people are using it, there's going to be a certain population that's interacting with you, coming back to you with pull requests and feedback.
Yeah.
But to sort of have an understanding of which portions of your library are being used for various people and to make decisions about refactoring, what to take out, what to keep, what to tune further, what's sort of the thought process that drives that?
That's a really hard thing to determine. For me, it's kind of watching all the GitHub issues come in is a really good place to start. If there's some parts of your code base that are tricky and unstable, I think it'll be pretty obvious if a lot of people are using it because they'll be complaining about it a lot. Unfortunately, I don't know, I've made a couple of bad calls myself. For example, there was a very vocal minority of people that were complaining about the JSON API and requests, so I changed it. So before it was a property to get the JSON deserialized version of a response, and then I changed it to a method call, specifically because the Facebook API doesn't care about status codes in the return, so there was no way to determine if the value was none because there was no JSON or none because there was an error. So I made it actually raise exceptions properly because you don't expect exceptions when you're accessing a property. And I mean, looking back at it, I probably wouldn't do that again because it's kind of inconsistent. If I was to do that now, I'd probably make all of them methods or all of them properties instead of kind of switching them around. And I feel like, I don't know, I feel like I just had to, if you just sit around and think about it for a while and kind of go with your gut, I think that helps a lot too. Like if I would have gone with my gut with that, because I was against it for a long time and I kind of caved to peer pressure and I really regret it. So I think, I don't know, it's a really tricky thing. I think it's different for every project and it's definitely the hardest part of maintaining a project, in my opinion. Continual learning process. Any more questions?
So when you're starting to write a project, you're usually in a dilemma like what features to include initially, what to exclude. So how do you decide on those? Like some are really awesome features but might take time to code, but some are very basic which a lot of people might use. So how do you decide on which feature to include when?
I think it depends on the audience you're going for. For me, I always try to just make everything fit the 90% of the users and ignore that other 10%. And I think that really goes a long way for me. So like Kerberos is a good example. I mean, how many people in this room interact with Kerberos on a daily basis? Like 4. So it doesn't make sense to include that in the main code base, especially because the maintenance burden is so high. But some simpler things like streaming responses, I bet very few people also use those, but they're pretty simple to implement and they're very powerful. So I kind of make a balance between things I want to see people using more. It's like I'd like to see people using streaming more. So I'll put the time into that to make it proper and make it elegant and nice, to try to kind of incite change. And then for the other things that, like I don't think people need to use Kerberos all the time, I'll exclude that and I'll try to make it so other people can do that instead. And I feel like having that, just kind of keeping in mind what your goals are and who you want to use your library and what makes sense for them, kind of helps a lot with that.
Thank you.
Kenneth, thanks, great keynote.
Thank you.
Just to add to that, what you were just asking, something that I have seen and I have often adopted in my code is that put the core features in my library and provide a plugin kind of API so that people can develop probably stuff like the Kerberos thing you just talked about in their own time, and it doesn't come in the code base but comes as contribs.
Absolutely.
Do you think this is a nice model for, to advocate to young developers who are getting into open source?
Absolutely. I think that's you think it's a good thing for them to write plugins, or you mean it's good if you make
Good
a
model
project?
for, what you just asked, don't put a lot of features right into your main code, but provide a plugin kind of architecture.
Yeah, I think that's the most valuable part of saying no to features, is in addition to keeping the code simple, is it kind of forces you to make things composable and have plugins and things like that. And it's it's really easy to just try to support everything, and that's how you have crazy code bases that get out of hand. And I think that if you have the pluggable, the plugin system and the way to compose things together, it makes the maintenance burden a lot easier. It makes users, it gives them a lot of power as users. And if you can keep the API simple for the plugin system, then it's definitely a good idea. That's unfortunately a tricky part. It's very easy to have like the urllib2 handler system, which who knows how that works. But if you can find a really elegant way to try to give it all that functionality, I think it makes the entire library a lot better, and it makes everyone's experience better. I don't think of any downsides from it at all.
Thanks.
I think that's it. Thank you very much, guys. I appreciate it.